everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is implementation of 3-address code. Here we are going to discuss what is the 3-address code, what is the implementation of 3-address code, what is the structure, how to generate 3-address code, and we are going to see few examples how to translate it and the advantages of the 3-address code. So here, what is 3-address code? 3-address code is nothing but it is an intermediate code. 3-address code is nothing but intermediate code. Here it is generated in the fourth phase of a compilation. It is used mainly for optimizing the compilers. Here in 3-address code, if we are having an expression is given, that expression is broken down into several separate expressions. We are going to break that expression into separate expressions. Why we are breaking that expression into separate expressions? Because here in 3-address code, we should have at most 3 addresses. If the given expression is having more than 3 addresses and more than 1 operator in the right hand side, so then we are going to break that expression into several instructions. By this, we can easily translate it into assembly language or machine language. Into assembly language. Here in 3-address code, we should have at most 3 addresses are used to represent any statement. To represent any statement, we should have only 3 addresses. So that should be it in the form of A is equal to B op C. Op is nothing but operator. Operator can be any operator, either plus, minus, multiplication, division, anything, any operator can be placed here. It is nothing but equal to, colon equal to is nothing but the assignment operator that will be represented in the 3-address code. Each 3-address code instruction has at most 3 operands. It is a combination of assignment and a binary operator. It is a combination of binary and a assignment operator. See here one example, A equal to B op C. So nothing but this is one syntax. Here what we are having, A, B, C are the operands. How many operands we have? 3 operands. So we should have at most 3 operands. And what is the operator I am having? Equal to operator and plus operator. So for this example, I can have A equal to B plus C. Here the operands are A, B, C are the operands, and equal to plus are nothing but the operators. Equal to and plus are nothing but the operators. So what is the structure of 3-address code? How we represent a 3-address code? The representation of 3-address code is result equal to operand 1, operator, operand 2. Operand 1, operator 2 and result. Here the operands can be, what can be the operands? It can be variables, or it can be constants, or it can be temporary variables that we are going to create during the compilation. Whatever the thing we are going to create during compilation, those are all nothing but the operands. The variables we can write A, B, C, or so the constant things can be there, or I can give some temporary variables. All these are nothing but the operands. What are the components here? Result is one component. What it does, result, it stores the result. Nothing but it stores the output of these operation. Nothing but if I am having addition operation, it does our addition operation and it stores the result. It stores whatever the thing I am going to get, that will be stored in the result. Operand 1 and operand 2 are nothing but the input values that we are going to give when we are going to execute or when we are going to simplify the expression. Operator is nothing but the what type of computation you want to do. I want to do addition, then we need to give plus operator. I want to do subtraction, we need to give minus operator. So nothing but the type of operation that should be done. So that is nothing but the operator. It can be of plus, minus, multiplication, division, power, anything. Any operator can be there. So let us see example. Source code. X equal to A plus B into C. So the 3-address code is nothing but it should have at most 3 addresses. Nothing but at most 3 operands should be there. So see here how many operands are there? 1, 2, 3, 4. 4 operands are there. It is not a 3-address code. Now we need to convert it into a 3-address code by simplifying this expression. How we are going to simplify this expression? We are going to break down this given expression into some parts, and then we are going to generate, or it can be easily translated to the assembly language. So what is having the highest priority here? B into C. So let me take one temporary variable and B into C. B into C. Now T2 is equal to what I'm having here, A. What type of operator I'm having? Plus. So B into C, where it is stored? In temporary variable T1. Now the whole thing is stored in T2. See here, T1 is nothing but I can have B into C. A plus B into C. The whole thing is stored in T2. Now X is equal to T2. X equal to T2. Check now it is in a 3 address format or not. Yes, it is in a 3 address form. It is having 3 operands and in the right side only one operator is existing. Here also there are 3 operands are there and 1 operator. Coming to here, I am having only one operator, one operand is there, there is no operator is there. So that is nothing but, this is nothing but it is, we can call it as a copy statement. The whole data which is existing here, I am going to copy it into some new variable or some variable we are going to copy. So this is also valid in a 3 address code. We'll see in the further. Here T1 is a temporary variable created to hold the intermediate result of B into C. We are going to store the result of B into C in the T1. How to generate a 3 address code? How to generate the 3 address code? So the given expression, what are the I am having the expression has 2 operators, equal to and plus. Even I am having plus 2 times. Generally, what are the operators are existing over here? Equal to and plus are the operators. To generate 3 address code for given expression, plus operator is having the highest precedence or more when compared to equal to. Plus is having the highest precedence. So plus operator is having the more priority when compared to the equal. Okay, so then here I am having totally other 4 operands are existing. Here I am having plus operator and here also I am having plus operator. When both the operators of same priority, when both operators are of same priority, which one should be evaluated? Nothing but at that time we are going to follow plus operator follows left associativity. Left associativity is nothing but first I need to evaluate B plus C and the result is added to this D. The result is added to this D. So let me see here. So first B plus C, that I am going to store in one temporary variable T1. I am storing it in the B plus C. Now T1 is holding B plus C. Now next T2 is equal to B plus C is there in the temporary variable, that is nothing but T1. So the next after C what I am having plus, next D. T2 equal to T1 plus D. The whole thing is available in T2. Now this T2 is assigned to A. A is equal to T2. A is equal to T2. A is equal to T2. So this is the way we generate the 3 address code. So what are the types of 3 address codes are there? We have many types, but here we are going to see 3 types which are used. Assignment statements are of the form. Assignment statements are of the form X equal to Y operator Z. X equal to Y operator Z. Here can be X equal to A plus B or Y equal to Z into Y, Z into B. Anything. These in the form of, these are nothing but operands and this is nothing but the operator. These are nothing but we are going to call it as assignment statements of the form. Next, copy statements. Copy statements. Actually, I told that in the right hand side, we should have at least one operator should be there. But coming to here, there is no operator. There is no operator. But it is nothing but we can call it as a copy statement. The data which is available or the output which is available in Y is allotted or stored in the X. Nothing but we are going to copy the content of Y to X. So that is nothing but we are going to call it as copy statement. So the next one is assignment instructions are of the form. Now, so here I can have here minus B. Nothing but what it is? Unary minus B. These are nothing but we can call it as unary operators. These are also we exist in the 3 address code. So it can be of assignment statements or it can be of copy statements or it can be of unary operators. Unary operations. Here I am having only one operator. Yes, in the right hand side it is a valid operator. Operator and Y. See here, the 3 address code will be T1 equal to B plus C. It is in the form of assignment statements. It is also in the form of assignment statements. It is in the form of copy statement. When we generate a 3 address code, we are going to concentrate on these two and this is nothing but it is a copy statement. So here for example, if we are given an expression, we are going to simplify that expression and we are going to generate this one. So this is copy statement, this is the copy statement, this is the unary operation, minus, plus, anything, any operation. So what it does is nothing but A equal to minus B is nothing but A equal to A minus B, right? So this is nothing but here, these are the things that are going to be done here. These are the types of 3 address codes. So the next one is implementation of 3 address code. Implementation of 3 address code. The 3 address code can be implemented as a record with address fields. We can implement these 3 address code with the 3 address fields. So the first one is quadruples, the next one is triples, and the next one is indirect triples. So these are the 3 types of representations of 3 address codes we have. The first one quadruples, triples, and indirect triples. So the first, how we are going to translate? Example of expression translation. How we are going to translate the example? X equal to A plus B into C minus D. Here, parentheses as having highest priority. So first eliminate the parentheses, then go for the operator precedence rule. So see here A plus B. So what I am having here, T1 equal to A plus B. The next is nothing but T2 equal to C minus D. Then in between, this is stored in T1, this is stored in T2. T1 into T2, that is stored in X. It is in the form of 3 address code. Plus 1 operator is existing and total 3 operands are there. Here T1 holds the result of A plus B and T2 holds the result of C minus D. Thus, they are multiplied to compute X. So the next one is implementation of 3 address code. So the 3 address code can be implemented in 3 types. The representations, the first one is quadruples, triples, and indirect triples. So the quadruples, the name itself tells us that here we are going to have 4 fields. We are going to have the 4 fields. The first one will be operator, the next one is argument 1, and the next one is argument 2, and the next one we are having is result. So nothing but we are going to have the 4 fields. Operator is nothing but which is used to represent the internal code for operation. B plus C, nothing but what type of operation we are going to do. That will be done by operator. Argument 1, argument 2 fields are nothing but the 2 operands which are used here. Result is nothing but here. The result is nothing but to store the result of the expression. After computing these 3, we are going to get the sum result that is stored in the result operator. So the quadruples consists of 4 fields, the operator, argument 1, argument 2, and result. So example, X equal to minus A into B plus minus A into B. So for these expression, so we need to construct the quadruple. So to construct the quadruple, first we need to do is, we need to generate the 3 address code for this expression. If suppose the given expression is in 3 address code, then no need to convert. If the given expression is not in a 3 address code, convert it into a 3 address code. After converting these 3 address code, by using these 3 address code, generate the quadruples. Generate the quadruples for the 4 fields. Clear? So see here, X equal to minus A. So minus A is nothing but what type of it is? Unary operation. It is nothing but unary operation. So I am going to store it in the T1 equal to minus A. T1 is holding this minus A. T1 is holding minus A. So the next one what I am having here, B operator is there. So T1, what is the here operation I am having? T2 equal to minus A is stored in T1. What is the operator I have here? Multiplication. The next one what I am having here? B. The next one is B. Now these totally is stored in T2. So same way here we are going for the next operation. So this is having multiplication and this is having multiplication. Then next these 2 results we are going to do the addition. So the next one is T3 is equal to minus A. T3 is equal to minus A. It is a unary operator. Minus A. Next T4 is equal to. So this is stored in which one? Minus A. That is stored in T3. T3 into what I have here? B. T3 into B. So now T4 is having T3 into B. So the next one we are having is T5 is equal, this totally is stored in T2 and this totally is stored in T4. So nothing but see here, T2 plus T4. T2 plus T4. So the next what we are going to do, X equal to This whole thing is there in the T5. Now this T5 is assigned to X. T5 is assigned to X. So this is the generation of a 3 address code. In this way, we are going to generate the 3 address code for the given expression. Nothing but we are going to call it as expression translation. We are going to take the expression and we are going to translate it in the form of a 3 address code. Now, for these 3 address code, we are going to generate the quadruples. So, the quadruples consisting of 4 fields. The first one is operator, the second one argument 1, third one argument 2, and the fourth one is result. Just for the numbers, I mentioned 0, 1 in the form. So, here, first expression, we need to evaluate here individually one after the other expression. So, T1 equal to minus A. So, what is the operator I have here? Minus. What type of operator it is? Unary minus. I have written here U minus. It is pointing to unary minus. Minus. What is the operator? Only one operator is existing. That is argument 1. That is what type of operator? A. And result is where? In T1. Result is stored in T1. So, the next one, T2 equal to T1 into B. Here what I am having, the first one is operator. So, multiplication. Next, argument 1 what I am having, T1. Argument 2 what I am having, B. And the result is stored in T2. Result is stored in T2. So, the next expression is minus. Unary minus. I am having operate only one argument, that is A. Argument A. And it is stored in T3. It is stored in T3. Next, here in the fourth statement, what I am having the operator? Multiplication. And what is the argument 1? T3. Argument 2 is B. And the result is stored in T4. Result is stored in T4. Next statement. Here what I am having operator is plus. So, plus operator. What is argument 1? T2. Argument 2 is T4. Result is stored in T5. Result is stored in T5. The next statement is X equal to. What type of operator I am having? Assignment operator equal to. So, what is argument 1? T5. Argument 2, no argument 2, and just if no argument 2 is available, just keep it as empty. Then the result is stored in X. The result is stored in X. So, this is about the quadruples. Quadruples consisting of 4 fields, operator 1, operator, argument 1, argument 2, result. And here just numbers I have mentioned, how many statements are there. For that representation, I mentioned these numbers. So, the next one is quadruples. What are the advantages of quadruples and what are the disadvantages of quadruples? By using these quadruples, easy to rearrange the code for global optimization. We can rearrange the code very easily. Here we can easily access the temporary variables. By using this table, we can easily access. Here we can easily access the temporary variables using symbol table. We can easily access these temporary variables. These are the advantages. Coming to quadruples, the disadvantages of using these quadruples is we have lot of temporary variables are there. According to this example, we have 5 temporary variables are there. So, we are going to create temporary variables, lot of memory is occupied. So, nothing but temporary variables creation increases time and the space complexity, and it takes lot of memory also. So, that is the disadvantage. To overcome this, we are going for the triples. To overcome this, we are going for the triples. In triples, temporary variables are not added to the symbol table. Coming to the quadruples, we are having temporary variables. By using that temporary variables, we are going to allot lot of memory and we are going to increase the time to create the temporary variables, and space is also, it takes lot of space. So, to overcome that, we are going for the triples. Here in these triples, temporary variables are not added. In these temporary variables are not added to the symbol table. Instead, they are referenced by the position of the statement. Instead of using the temporary variables, at which position it is there, nothing but by using these indices, we are going to represent the triples. So, here the given expression is this. So, first you need to convert it into the 3 address code. After converting it into the 3 address code, then we are going to place it in the form of a triples form. So, to generate these 3 address code is, so T1 is equal to minus A, T2 is equal to T1 into B, T3 is equal to minus A, T4 equal to T3 into B, and T5 equal to T2 plus T4, X equal to T5, which we have generated for quadruples. which we have generated for quadruples. Okay, it is in the form of a 3 address code. It is not in the form of a 3 address code because here we are having more than 3 addresses are there. The 3 address code should have at most 3 addresses, and in the RHS side we should have only one operator. But it is not in the form of a 3 address code. We have simplified it in the form of a 3 address code. And now for these 3 address code, we are going to generate the triples. The triples consisting of 3 fields. The first field is operator, and the second one is argument 1, and the third one is argument 2. So the triples consisting of 3 fields, operator 1, argument 1, argument 2. Here in triples, we don't use the temporary variables. Here we don't use the temporary variables. Instead of using these temporary variables, what we are going to do is, we are going to use the position of the statement. At which position it is there. So it is 0 index, it is 1 index, it is 2 index, it is 3 index, and it is 4, and it is 5. These are the positions we are going to use. See here, so how we are going to generate the triples. So the first one, what I am having, minus operator. So nothing but I can call it as unary minus. Why? Because I am having only one operand. So it indicates that it is a unary operator. And the argument 1 is A. So here we are not using the temporary variables. So the positions we are going to mention. So here in the quadruples we have used T1, but here we are going to use the position. Any positions you can give. Here I have mentioned it with 0 position. 0 position. Now first statement is completed. Now next go for T2. So the next statement. So what I am having here, multiplication operator. And what is the operand I am having here? B is the operand. So T1. T1 is nothing but, what it is? T1 is nothing but address, nothing but the position. At what we have given in the place of T1? 0. So nothing but 0 into B. 0 is nothing but, what I am having? 0 is nothing but unary minus A. So what it is? The first index is, first position, it is nothing but U minus A into B. This is pointing to first index. 0 is nothing but 0 takes the position. So at 0 index, what is the thing we have? U minus A. So the next statement is minus, nothing but U minus A. So which position? 0, 1, 2. I am going to give it in a order. So it is in second position. Next here multiplication. And next what I am having? T3. So T3 is nothing but what I am having previous one. So T3 is nothing but what? Second position. Nothing but the second index into B. So let me take for your reference T1, T2, T3, T4, T5 and T6. Not T6, it is X. So T1 is nothing but 0. See here, T1 into B. T1 is nothing but what index? 0 index. Now here T2 is nothing. See here T3 is nothing but second index. It's complete. So the next statement, what is the operator? Plus operator is there. So next T2 is nothing but what I am having here? One position, 1. And next T4 is nothing but what position? Third position. Next equal to operator. What is the argument I am having here? X. So what is the index position what I am having here? T5 is nothing but what position I am having here? Fourth position is there. Here we are not going to mention any result. So that's why we have placed it in the argument 1 and argument 2. So this is nothing but triples. Here we don't mention the temporary variables. For your reference to understand, I just placed T1. We don't place here 0 is nothing but the positions we are going to use instead of temporary variables. Coming to the quadruples, we have used temporary variables T1, T2. Here we are going to mention the positions 0, 1, 2, 3. Like that we are going to mention the positions. This is nothing but the triples. So coming to the indirect triples. So the just difference for the triples and the indirect triples is, here in indirect triples, we are going to maintain one extra pointer variable. So what is this use of this pointer variable is, here in the triples, we have used these positions. Now coming to these indirect triples, we are going to use the address of that position. So that is the difference for triples and indirect triples. Here 0. See here we have mentioned 0, 1, 2, 3, 4, 5. So in the place of 0, 2, 1, 3, 4, we are going to use here addresses. Instead of using the 0, 1, 2, 3, 0 means at 0th position, what address is allocated? Nothing but by using this pointer table, we are going to use, or we are going to do the indirect triples. Indirect triples are solved by using a pointer table. By introducing a pointer table that references the instructions indirectly. This enables the instructions to be reordered freely without affecting the references, since the pointer tables can simply be updated. So here, let me take the same example. X equal to minus a into b plus minus a into b. So what we are going to do here is, this is stored at 0 index. Nothing but 0 is equal to minus a. 1 is equal to 0 into b. 2 is equal to minus a. 3 is equal to 2 into b. 4 is equal to 1 into 3. 5 is equal to x. 5 is equal to x. So these are the statements that we are going to use. So 0. See here, 0 is nothing but u minus a. Unary minus a. Next, multiplication operator. Here argument we have actually is 0. So 0 is nothing but, what is the pointer variable? What is the address of these 0? Is nothing but 20. So instead of 0, we are going to plus 20 into b. Next, third, u minus a. It is in second position. Fine. So the next one is multiplication. Next, 2. 2 is nothing but, what address I am having? 22 into b. Next, plus operator is there here. Plus operator plus 1. 1 is nothing but 21. 3 is nothing but 23. 21 plus 23. So 21 is nothing but, I am going to have this 1 index, and this 23 is nothing but, I am going to have this third index. Next, I am having 5. 5 is equal to x, and it is stored in which address? 24 address. So the whole thing we are going to assign over here. So this is nothing but the indirect triples. The whole thing we are discussing here with 3 things. 3 address code we are going to generate for this expression. So what I am having, b into minus c plus b into minus c. It is not in a 3 address code. So we are going to convert it into a 3 address code. Nothing but we are going to simplify the given expression by using 3 address code. So this is nothing but the 3 address code generation. So T1 equal to minus c. T2 equal to b into T1. This is nothing but T1. This is T2. This is T3. This is T4. And the whole thing is stored in T5. See here, T1 equal to minus c. Next, T2 equal to b into T1. Next, T3 equal to minus c. T4 equal to b into T3. And T5 equal to T2 plus T4. We have got here a equal to. Right? So now, for this quadruple, we are going to have 4 fields: operator, argument 1, argument 2, and result. In the operators, what are the operators we are going to have? We are going to place operator. Argument is C, the first statement. It is stored the result in T1. Next, T2. T2 is the result, and B is the argument 1 and operator, and we have T1. Next, T3 is the result. U minus is nothing but minus, and C is stored over here. And next, what I am having, T4, and B is argument 1 and T3 is argument 2, and that is done by multiplication operation. Next, T2, T4, and plus operator is there here, and the result is stored in T5. The whole thing is nothing but assignment T5, and the result is stored in A. So this is nothing but quadruple for the given expression. Now for these quadruples, we are going to optimize these quadruples into triples by eliminating the temporary variables. We are going to eliminate the temporary variables. Here we are having 4 fields, and coming to the triples, we are going to have the 3 fields. We are going to remove this result field in the triples. We are going to store the result in the indices, in the positions itself, and we are going to use it. See here T1, nothing but it is stored in the 0 index. Now instead of T2, so what we are going to have? B into what I am having, T1. T1 is nothing but what it is? 0 index. So, B into 0 index. 0 index is nothing but minus C. Next, T2 is nothing but second position I am having minus C. And the third position I am having into B. This one we are going to use it. Here we are having is T3 we are using. So, it is temporary variables. Here we are going to use the indices. Nothing but we are going to use the positions. So, here again 4 is nothing but plus and 1. 1 is nothing but B into minus C and 3 is nothing but B into minus 3. So, nothing but first position and third position are used over here. And next 5 is equal to fifth position we are going to do the assignment operator. For which one? This fourth one we are going to do the assignment operator. So, that is stored here in triples. Coming to the indirect triples, the difference is for the triples and indirect triples is only there is a slight difference is there. That is, we are going to use the pointer table. The extra thing we are going to use in the indirect triples is we are going to use the pointer table. In this pointer table, we are going to store the position and that position is stored at which address? That addresses we are going to use over here. That addresses we are going to use over here. So, here 0 is nothing but I can take it as 35. We are taking it as 35. 2 is nothing but 37. 1 is nothing but here 36. Plus 3 is nothing but what I am having here? 38. Addresses we are going to just use it. So, that is nothing but the difference for the triples and the indirect triples. So, today we have the next one is advantages of 3 address codes. What are the advantages of using these 3 address code? It simplifies the complex computations. Nothing but the complex expressions we are going to simplify. We are by breaking down the complex expression by applying the 3 address code by using some temporary variables. We are going to simplify that expression by breaking that complex expression. It enhances code readability. We can easily read the code. So, next one is enables optimization. We have multiple duplicate variables or temporary variables are there. We can also optimize the generated 3 address code. For the given expression, we are going to generate the 3 address code. That 3 address code, still we can optimize it. The same expression or same operation is done twice like that. If it is there, we can optimize that thing. So, that is nothing but we can also have the optimization phase. Allows implement like common sub expressions, elimination and loop optimizations. All these can be optimized here. By doing that, improves the performance of the generated code. It improves compilation efficiency. So, the 3 address code is nothing but it is acting as a bridge between the high level code and the machine specific instructions. It generates the intermediate code. The intermediate code is nothing but here we are going to have the 3 address code. The 3 address code is nothing but it consists of the temporary variables and it should have at most 3 addresses. It reduces the complexity of the compilation process. So, we can reduce the compilation process by reducing the or by translating the given expression into 3 address code. So, today we have discussed what is the implementation of 3 address code, how to implement the 3 address code and what is the structure of a 3 address code, how to generate a 3 address code and what are the how we can represent a 3 address code. So, we can represent the 3 address code using quadruples, triples and indirect triples. And we have also seen what is the structure of the 3 address code and how to translate the given expression. If an expression is given, we can check whether it is in 3 address code or not. If it is not in a 3 address code, we are going to simplify the expression into 3 address code. So, these are the things we have discussed here. Thank you.